Okay, so we've done the division, divided this by this. Did I divide correctly?
Yeah.
Now, here's the summary statement. What does this mean? You did the division. What does this mean? What is this? X to the second plus x plus 4.
The remainder of 21.
And the remainder is 21 over x plus 3. So there's your summary statement. That's all they mean. They just want you to do the division and then write down what your answer is. Now, is x plus 3 a factor of that polynomial?
No.
No, why not?
Is that a remainder?
The remainder came out to be something other than 0, right? So when I move to the next question, and it says, is this a, well, it doesn't say this exactly, but we're going to find the remainder, and the only reason we ever want the remainder is to see if it's a factor or not. One way of figuring out if this thing is a factor or not, one way of finding the remainder is to just do the division, right? But who remembers the other way of finding the remainder? It's the way I use all the time. I shared it with you, said you didn't have to use it, but I shared it with you. What is it, Jamie? You just plug the number in. So another way of finding the remainder, and this exercise does say use the remainder theorem, which means pretend this is a function and plug in the number that you would have divided by. So if I were going to do synthetic division on this problem, what would go out here in the box? -3. So that's the number I'm going to plug in. So I'm going to put in -3 cubed. What's -3 cubed? -27. -3 squared is 9, so -9. -6 minus 1, well, this is certainly not a factor, but what does all that add up to?
-43.
Negative what?
43.
Is that right? Yeah. If we would have done the division, which the directions ask you not to, but in the real world, it would be fine to do the division. Notice, what did we get for our remainder? Same thing, right? Now, I want you to look at this problem right here, though. If I want the remainder of this division, I am not going to synthetically divide. Why not, guys?
You're missing. Because you have
Remember,
to put like
in
zeros
synthetic division, if any power is missing, you have to put in a 0. So if I were going to do synthetic division, I'd have a 1 and a 1, but then I'd have about a zillion zeros in here.
90.
Yeah, a lot. And it would last a long time, be a big problem. So I do not want to divide that. If I want to know, is this a factor? Then I am going to do what? Plug what number into this thing? Plug in 1. So if I pretend this is a function and plug in 1, I get 1 to the 100th plus 1 to the 99th plus 1 squared minus 3. What's my conclusion? It is a factor. No division. Too big.
When we do synthetic division and none of the powers are missing, but one of your answers is 0, what would you do then?
You mean one of these numbers down here
Yeah.
was 0? Okay, so let's say you did the division, let's just use this as an example, and that came out to be 0, then that would just mean this was plus 0x. So I wouldn't even write it down. I would just say x squared, no x's, plus 4.
Okay.
Yeah, that will happen more often than you think, actually. Good question. Okay? All right. And then, is this a factor of this? And one more example that's a question straight out of the book. Is it a factor? What are you going to do? You have two options. This is only to the third power, so could you divide?
Yep.
That would not be a problem. You could also plug in 1. Remember, you're gonna plug in exactly the number that you would divide by. Plug in the same thing. So 1 minus 1 plus 1 minus 1, the answer is 0. Pretty easy? All right, there's one time when things can be a little bit complicated. And that is if we want to know this question. Now, what makes that a little bit more complicated?
The fact that that's not single.
Yeah, the fact that this is a quadratic thing and not just a little x minus 2 or something like that. We cannot do synthetic division, which means we're going to have to do what? Long division. So we're going to review that. You've all long divided before. I heard somebody say, I hate this. I'm with ya. I don't like it either. But it's fact of life. So here we go. We're going to do this long division. Let's just come to understanding at the beginning. Where you write things up here is completely irrelevant. I know I don't appear to be organized, but I do have this thing about keeping everything neat and orderly. So I'm going to ask myself, what would it take times this x squared right here to get this x to the 4th? Another x squared. I'm going to write it over here because I like everything lined up. If you write it here, it does not matter. It's totally irrelevant. Now I'm going to take that x squared times each of these. So that gives me the x to the 4th that I had planned, a negative 4x cubed, and a positive x squared. So I said to myself, what do I need to take times this x squared to get this x to the 4th? You said x squared. So now I'm going to take that x squared times all of these. Now I'm going to subtract. These will cancel. If they don't, you have messed up. I mean, that's the purpose. You want those to cancel. So now I have an x cubed, a 3x squared, and I'm going to bring down my next term, which is a 9x. And I'm going to start all over again. What do I have to take times this x squared
Just
to
that.
get this x cubed?
X to the first.
Just an x. So I'm going to put plus x. Now I'm going to take that x times each of these. So that's x cubed minus 4x squared plus x. Now what am I going to do? Subtract. And I've got, I'm going to write it up here. I'll write down here first. So that's 7x squared plus 8x. And then I'm going to bring down my negative 8. So I have my 7x squared, my plus 8x, and my negative 8. Now I start all over again. What do I have to take times x squared to get 7x squared? 7. So then I'll take that 7 times all of these. That would give me 7x squared minus 28x plus 7. Remember, that's supposed to be written down here. And then what? Subtract. So I have 36x minus 15. Now wait a minute. I'm out of numbers to bring down, right? And there's no way I can multiply x squared by something and get 36x. So what's this?
Remainder.
That's my remainder. So if I'm writing a summary statement like I was in that first problem we did, it would be this. There is my quotient and my remainder. You may long divide anytime you want, but you have to long divide if you're dividing by something other than a little binomial. Okay? All right. That's enough. We're going to stop for the day. You've got 3 minutes. You can start your homework if you want. How were the quizzes?